Hello everyone, very good evening. I hope you all are doing well. Very good evening, Nirali. You are joining for the first time? I didn't see you before. Anyway, welcome to the class. So today in the class, what we are going to do, we are largely left with question solving. Only two concepts are left. That is your Wheatstone bridge and meter bridge. Okay. But before we move on to the left concepts, let's have हैंड एट सेवरल क्वेश्चंस. ठीक है, तो चलो हम लोग क्वेश्चंस ट्राई करेंगे. सो दिस इज द वेरी फर्स्ट क्वेश्चन. व्हाट यू वांट टू डू इज आई वांट यू टू कैलकुलेट current, voltage across 11 ohm resistor in the circuit given here. Okay, you solve it and let me know what answers you're getting. Done it? Chalo, your time starts now, so start doing it. You have to calculate voltage drop across 11 ohm resistor. Yes, anybody with the answer? Yes, please let me know answers if you have got. Anyone? No answers? Chalo, let me discuss the question. What you are asked voltage drop across 11 ohm resistor. So how to solve this circuit where we are having two batteries and two different loops, you can say. Branches are, there are two loops. This is loop one. This is loop two. We can see here like this. Done it? So how to solve such questions where you are getting more than one battery, more than one loop? Done it? First, you just take the current coming out of any one battery. ठीक है? Which battery to select? Preference कहाँ पे देना है? So you just look for which battery is having more potential. ठीक है? So 19 volt is having more potential than 10 volt. So what I will do is I will take current coming out of 19 volt battery, and here coming out current is how much? It is I, and it is going like this. Done it? When current I will reach here, here it has two branch to go into. So take current coming here as I1 and current coming here as I2. And then again at this point, current I1 will come from here and current I2 will come from here, and here I1 plus I2 will go. So here I1 plus I2 will go, and this will be equal to how much? I. So देखो, दो चीजें यहाँ पे सीखनी है. फर्स्ट थिंग ये कि if you are having more than one battery and these batteries are not in series or parallel, we can see here they are not in series or parallel. If they are not in series and parallel, you cannot use any formula to calculate net equivalent or net EMF of the circuit. नहीं निकाल सकते, ठीक है? In that case, select any one battery. Which one you will select having higher potential? Take current I coming out of it, and then according to uh, Kirchhoff's current law, keep on dividing the current. So I divided current at point A, I1 into I1 and I2. And again, these currents are coming at point B, I1 and I2. They will get added to give I1 plus I2 equal to I. Now we need to calculate potential drop across 11 ohm. Potential drop across किसके निकालना है? 11 ohm. So if we know what is current flowing through 11 ohm, then voltage drop will be current flowing through 11 ohm into resistance, that is 11 ohm, right? So if we know what is current flowing through it, what is current flowing through it? I. Current क्या है? I है current flowing here. So basically we need to calculate I. So to calculate I, what we will do now? आप केवीएल लिख लो, कोई भी एक लूप सेलेक्ट करो, ऐसा लूप सेलेक्ट करो जिससे कि केवीएल के हेल्प से instantly you are getting the value of I. I mean here we can select the bigger loop. ये बड़ा वाला लूप सेलेक्ट कर लो. I mean let's say this is this is O P, this is Q, this is R. So select the loop O A P Q V R O. ठीक है? That bigger loop I am telling. So let's move from R. Let's start moving from R. Which loop I have taken? R, R O A P Q B R. This is the loop. This is the closed loop we are taking. ठीक है? अब आप KVL लिखो. R से start करो. VR. First we are getting battery. We are traveling from negative terminal to positive terminal. So plus 90. Along 11 ohm, we are traveling in the direction of current. So minus sign we will give I into R, that is 11 ohm. And this is equal to how much? Again, this side we will go now. From A to P, there is nothing. From P to Q, there is a battery. And we are traveling from negative to positive terminal. So again, we will write 10 volt hai na? So we will write here 10 plus 10. Now Q to B, there is nothing. B to R, there is nothing. So right here, VR. We needed to calculate current through 11 ohm, that is I into R. So I into R we have to calculate. That is this thing we have to calculate, right? So from here, I into 11 is equal to how much? This is equal to 29 volts. So correct answer will be 29. If you are asked what is the value of current you can write I equal to 29 by 11 ampere. So I is 29 by 11 ampere. If you are asked I2, तुमसे अगर कोई पूछता है I2 बताओ, तो I2 लिखने के लिए आप क्या करोगे? You already know I by writing KVL in the bigger loop. Now you write KVL in this smaller loop. इस loop में लिख लो, क्योंकि इस loop में there is I2 flowing through 4 ohm. So for if you will write that, you will get I2. जैसे अगर मैं यहाँ पे लिखूं O से चलकर R तक पहुंचू, so VO minus 11 into I, that is 29 by 11. फिर इधर जाओगे इन द डायरेक्शन ऑफ करंट माइनस I2 into 4. अगेन आर पोजिशन पे पहुंच रहे हो. Again you will travel across the battery from negative to positive. So this is plus 19 equal to VO. This will get cancelled. And here this is equal to how much? 19 minus 29 plus 19. So that is basically your 10. And this is I2 into R. R is how much? R is your 4. So I2 is equal to how much? 10 by 4 ampere. KVL likhkar we have calculated it. We can do it otherwise also. So I will let you see that also. जैसे हमारा यहाँ 4 ohm था, and then there was a battery here. This battery was having potential of 10 volt. Then there was another resistor like this. Then there was a battery like this, like this. ऐसा ही था ना? Yes. There was nothing else, right? So this is your 29 volt. इस क्वेश्चन को हम और कैसे सॉल्व कर सकते हैं? I mean, if you really have good practice of solving current electricity, you can easily solve it by just looking at the circuit. In that case, you will not require to write KVL so much. जैसे ध्यान से देखो, ये वाला end is directly connected to the negative terminal. This end is directly connected to the positive terminal. Let's say this is A, this is B. So what is potential difference across A and B? अगर आप A and B के क्रॉस पोटेंशियल डिफरेंस निकालोगे तो दैट विल बी इक्वल टू द पोटेंशियल डिफरेंस ऑफ बैटरी बिकॉज दिस टू एंड्स आर डायरेक्टली कनेक्टेड टू द टर्मिनल्स ऑफ बैटरी. ठीक है. सो Dhanush, which thing you are talking about? Previous KVL or right now what I'm dealing with?
KVL.
Okay. Okay. Where you got stuck? The whole thing?
Wheel
Okay.
11 is
ओके. ठीक है, चलो एक काम करती हूँ, फिर से एक्सप्लेन करती हूँ. लेट मी रिमूव एवरीथिंग. So what you were required to do is you were required to calculate potential drop on 11 ohm. यही निकालना है ना. So I request everybody to follow things properly. ठीक है, तो फॉलो करो. सबसे पहले क्या करेंगे, इन द सर्किट वी आर हैविंग टू बैटरी. ठीक है, तो पिक एनी वन बैटरी, टेक करंट आउट ऑफ. which battery you will pick? The one having higher potential. So here 19 volt, I'm picking it. पॉजिटिव टर्मिनल से करंट आएगा. सो आई करंट मैंने लिया, अज्यूम किया. तो आई करंट ऐसे फ्लो किया थ्रू 11 ओम. हाउ मच करंट इज पासिंग? आई करंट. सो व्हाट विल बी पोटेंशियल ड्रॉप अक्रॉस 11 ओम? व्हाट विल बी पोटेंशियल ड्रॉप अक्रॉस 11 ओम? ओम्स लॉ को यूज करो. पोटेंशियल ड्रॉप इज इक्वल टू व्हाट? करंट फ्लोइंग थ्रू द रेजिस्टर into resistance of the resistor. So here current flowing is I and resistance value is 11. तो बेसिकली वी नीड टू कैलकुलेट 11 I का वैल्यू. ठीक है, उसके बाद मैंने यहाँ पे देखो करंट यहाँ तक आएगा I. यहाँ पे देर आर टू ब्रांचेस, इट विल गेट डिवाइडेड हियर. लेट्स से दिस इज योर I1 एंड दिस इज योर I2. ठीक है, डिस्ट्रीब्यूशन क्लियर है एवरीवन? डिस्ट्रीब्यूशन क्लियर है? चलो स्टेप बाय स्टेप में जाऊंगी. इस डिस्ट्रीब्यूशन क्लियर द वे आई हैव डन? ओके एवरीवन, थैंक यू. ठीक है, क्लियर है. उसके बाद क्या लिखोगे? उसके बाद आप लिखोगे केवीएल लिखो, क्योंकि आई निकालना है. ठीक है, एंड वी कैन नॉट अप्लाई डायरेक्ट ओम्स लॉ टू कैलकुलेट आई, क्योंकि हमें नहीं पता सर्किट का ई इक्विवेलेंट क्या है, आर इक्विवेलेंट क्या है. वी कैन नॉट लुकिंग एट द डायग्राम वी कैन नॉट से एनी ऑफ दिस थिंग्स, राइट? सो हमें उस केस में हमें क्या करना चाहिए? केवीएल लिख लेना चाहिए. सो यहाँ से मैंने सपोज मार्क कर दो पॉइंट्स को ए बी C, D, E, F, like this. So let's write KVL in the bigger loop. A, B, C, D, E, F, A. ठीक है. So start moving from A. मैंने A से I started moving from A. A से अगर आप मूव करोगे VA, सबसे पहले मिला बैटरी. बैटरी के क्रॉस आप कैसे जा रहे हो? पॉजिटिव, नेगेटिव टू पॉजिटिव, सो प्लस साइन 19. And across current, how you are going? In the direction of current, so negative sign I into 11. Across every element we have to write the potential difference. So across register it is I into R. So ये मैंने लिखा. C से D there is no element, circuit element. From D to E there is a battery, and D to E we are moving from negative to positive terminal. So again plus sign 10. From E to F there is nothing. From F to A again there is nothing. So we have reached A. Done it. And A you will cancel here, and I into 11 is, sorry, I into 11 is equal to how much? 29. So current through the circuit, current in this branch that is coming out from 19 volt is equal to 29 by 11. And hence potential drop across 11 will be I into 11. So that is equal to 29 by 11 into 11. Okay, so that will give you 29 volt. Because here I into 11 is equal to 29 by 11 into 11. That is 29. Is it clear? If yes, let me know. Okay, Karthik. Uh, Someone asked me the doubt.
Ma'am,
Yes.
ma'am,
Yeah.
across 4 ohm, the current will not count.
Which current?
See that I from 19 volt comes and as well as from the 10 volt also. That across 4 ohm, it will not count. It will not do anything. Will not take that.
Yeah, we are not. I mean, it depends on which loop you are taking. So we have taken A, B, C, D, E, F, A. So in this loop, 4 ohm is not coming. So whatever loop you are taking, उसी के along चलना है. So work along that loop. Whatever is coming, you write. Whatever is not coming, you ignore.
Okay, okay.
So if you're supposed to calculate I2, in that case, you need to select a loop in such a way such that in that loop, 4 ohm arm will be there. So that loop can be A, B, C, F, A. Okay? So that way we can go. Yes, Kiran, we can take another branch. To the long we are getting the answer, we can take, but we only take the we only select that branch from which we can easily get the answer. जैसे अगर यहाँ पे आप ब्रांच ये ले लेते हो, सपोज कर लो आपने ले लिया ए बी सी एफ ए, इस ब्रांच से अगर आप लिखोगे ना, अगर मैंने ये ब्रांच नहीं लिखा एंड आई एम डायरेक्टली राइटिंग केवीएल इन दिस ब्रांच, देन आई विल बी गेटिंग व्हाट, ए से चलो VA plus 19 minus 11I and minus 4I2 and equal to VA. अब देखो यहाँ पे दो वेरिएबल है I and I2. You don't know either of this. ठीक है? Kiran, this is answer of what? ये किस चीज का आंसर बता रहे हो? प्लीज कैन यू क्लैरिफाई? ओके I2 नहीं, I2 तो आ रहा था ना 10/4. I2 was 10/4. अगर यहाँ से भी सॉल्व कर लो, I2 को सॉल्व कर लो यहाँ से, बिकॉज वी हैव ऑलरेडी कैलकुलेटेड I बाई राइटिंग केवीएल इन द बिगर लूप. अगर आप लिखोगे यहाँ से ए को कैंसिल कर दो, 19 माइनस 11I, 11 लिखो यहाँ, I लिखो 29/11 and this is equal to 4I2. Done है? This will get cancelled. This is equal to 10. 10 is equal to 4I2. So I2 is 10/4. It cannot be that. Recheck your calculation. ठीक है? Done it? I was just talking. Please do practice more question. I will suggest, highly suggest. तुम लोग अगर question नहीं करोगे ना, बहुत मुश्किल होगा. I'm telling you. Please everybody go through things. ठीक है? I was talking about another method, but मैं कैसे बात करूँ यार another method की? तुम लोग करते नहीं हो लगता है. Lakshmi, you don't need to write all the steps. If you are directly getting the answer, you can write the answer. Prime task is what? To get the answer, right? In your competitive exams, I mean, the one who is checking your copy, digital way it is getting checked. It is not bothered about which steps you wrote. It is only bothered about what answer you got. So, to the long you're getting the answer, it's not a problem. Now, I was talking about how easily you can calculate current across 4 ohm and all. यहाँ से ध्यान से देखो, what is the potential difference across this branch? अब देखो मैं ज्यादा बच्चों जैसे एक्सप्लेन नहीं करने वाली हूँ, क्योंकि ये पोटेंशियल टर्म को मैंने बहुत एक्सप्लेन किया है. ठीक है? सो नाउ आई विल बी राइटिंग डायरेक्टली. जैसे देखो यहाँ पे डिफरेंस इस ब्रांच के क्रॉस 10 वोल्ट है, तो इस ब्रांच के क्रॉस भी डिफरेंस क्या होगा? 10 वोल्ट, क्योंकि जो पोटेंशियल इस पॉइंट का है वही पोटेंशियल इसका होगा, जो इस पॉइंट का है वही इसका होगा. सो अक्रॉस ए एंड बी पोटेंशियल डिफरेंस इज 10 वोल्ट. Across A and B here, it will be also 10 ohm. So if across 4 ohm potential difference is 10, then current ohms law से निकाल लो, V equal to IR. V is how much? 10. I is we don't know. I2 हमने लिखा था इसके across. I2 into R is 4. So I2 क्या आ रहा है 10/4. We can easily write this. For this we don't need to write KVL here. क्योंकि यहाँ पे जो इसका डिफरेंस होगा वही यहाँ पे होगा. ठीक है. So you already know what is going to be current through this 4 ohm, right? Then if you know current through this branch, you can easily calculate current through this branch by writing KVL in this. Or either you write KVL in the big loop, you get potential drop across this. Okay? This thing I told you so that you can have an idea of what different things you can utilize. चलो अब इस क्वेश्चन को ट्राई करो. प्लीज ट्राई इट एवरीबॉडी. ठीक है. दिस इज अ सिंगल लूप सर्किट है ना. यहाँ पे लूप सिर्फ क्या है, एक ही लूप है. इन द प्रीवियस क्वेश्चन देवर 2 लूप्स. दिस इज अ सिंगल लूप सर्किट. और जब भी सर्किट सिंगल लूप होगा ना, थिंग्स इफ देयर आर मोर देन वन बैटरी दे आर इन सीरीज. ठीक है. क्योंकि इफ देयर इज अ सिंगल लूप, बैटरीज आर कनेक्टेड एंड टू एंड. डन है. सो इसका हाईलाइट क्या है इस क्वेश्चन का, दिस इज अ सिंगल लूप सर्किट. एंड सिंगल लूप सर्किट का मतलब क्या हुआ, सारे आर सीरीज में होंगे और सारे बैटरीज के ईएमएफ भी किसमें होंगे, सीरीज में होंगे. सारे ही सीरीज में होंगे. So if you have to calculate current in the circuit, calculate E equivalent, calculate R equivalent and solve it. Okay. Okay, somebody got this, maybe. नहीं, तुमने E equivalent सही से नहीं निकाला. Whoever has given me answer now, let me recheck. लक्ष्मी एक बार E equivalent सही से चेक करो. तुमने वहां पे मिस्टेक किया है. R equivalent तुमने सही निकाला. E equivalent निकालने के लिए मैंने क्या बोला था, if they are in series, check the current orientation first. If current orientation is opposite, they will get subtracted. If it is same, it will get added. So first you check with that, please. Yes, Kiran. जैसे देखो, अगर हमने जो प्रीवियस यूज किया सेम चीज को यूज करें. सर्किट में क्या है, 2 बैटरीज है. जो बैटरी बड़ा है उससे आप करंट को निकालोगे, छोटे बैटरी पे ध्यान नहीं देना. सो करंट ऐसे निकला. इफ यू टॉक अबाउट दिस करंट आई, देन सेम करंट विल गो थ्रू R2, R3 and also through R1. So all are in series, right? R equivalent आप क्या लिखोगे, 6 plus 4 plus 2. So that is going to be how much, 12 ohm. R equivalent is 12 ohm. Now लक्ष्मी कैसे कैलकुलेट किया, नहीं वो तो नहीं आना चाहिए. अब आप E equivalent निकालो. They are in series, right? This is a single loop circuit. All elements are in series. Now, if you talk about 9-volt battery, it has tendency to send current in this direction. And if you talk about what? If you talk about 3-volt battery, it has tendency to send current in दिस डायरेक्शन. दोनों डायरेक्शन सेम दिख रहा है, लेकिन अगर आप ध्यान से सोचो, ये करंट ऐसे भेजेगा एंड इट इज सेंडिंग करंट इन दिस वे. आर दे ऑपोजिट और सेम? One is sending current in the anti-clockwise direction, another one is sending current in the clockwise direction. So yes, Kiran. धनुष गलत आ रहा है गेस. तो E इक्विवेलेंट क्या होगा, 9 - 6 होगा. कितने लोग अग्री कर रहे हो उसके बताओ. Sorry, not 6, 9 - 3. Because E2 is 3 volt. How many of you agree with this? Let me know. Okay, Karthik. Kiran, you asked something, I guess. You raised your hand. Agree? Yes. Others, where are others? ठीक है, तुम्हें agree करना पड़ेगा because this is truth.
Yes.
One is sending current in the clockwise sense, another in anti-clockwise sense. Both are oppositely directed. ठीक है? तो चेकिंग में अगर कुछ लोगों ने गलती इसलिए किया क्योंकि क्यों क्यों गलत किया तुम लोगों ने, शायद तुम्हें ये लग रहा था ये करंट राइट की तरफ सेंड कर रहा है, ये भी करंट राइट की तरफ सेंड कर रहा है, बट ट्राई टू सी इन लूप हाउ दे आर गोइंग इन लूप, आइदर दे विल गो इन क्लॉकवाइज डायरेक्शन, एंटी क्लॉकवाइज डायरेक्शन. इफ दे आर सेम, add it. If not, subtract it. So this is 6. Nobody gave me the right answer, I guess. करंट क्या होता है? करंट होता है E इक्विवेलेंट बाय R इक्विवेलेंट, राइट? क्योंकि ओम्स लॉ से क्या पढ़े हो? V इक्वल टू आई आर. आई इज V बाई आर, राइट? Somebody, everyone gave me the answer of 6 by 12. Sorry, 12 by 6. So 0.5 volt. Okay, somebody gave me the correct answer. Sorry. Shravya, Kiran, Yash. मैंने ही गलती करी actually. It's not your fault. It's my mistake. Sorry. ठीक है? So this will be the answer. It was that simple. Now find I and let me know. This is question directly from KCL. जल्दी से आंसर बताना without taking much time. Please do it and let me know. Anyone? जल्दी से आंसर बताओ आप लोग. Whatever you are getting. KCL use करो. Whatever current is coming to the junction will be equal to whatever current is going out of the junction. Done it? Yes, Ravya, very good. That's great. Yes, Kiran, सही है. Okay, so KCL क्या कहता है? Whatever current is coming to the junction, how much is coming? 0.2, 0.6, 0.7. So 0.7 plus 0.2 plus 0.6 is coming to the junction. How much current is going out of the junction? This is 4 and this is I and this is 0.5. So 0.4 plus 0.5 plus I. This has to be equal to this. So this and this will get cancelled because both are equal to 0.9. So I is equal to 0.6 ampere. So this is going to be your answer. Yes, Kiran, that's correct. Lakshmi, yes. Chalo. Now do this question and let me know your answer. Calculate the current that flows in the 1 ohm resistor. What current will go in this branch? You apply KVL and let me know. Distribute the current first, then apply KVL and let me know. Okay? I'm giving you 2 minutes of time. Do it. Done it? Chalo. Yes, are you people doing? See, is it happening? Priya, Mahesh, Latika, गौरी, हो रहा है सबका? चलो करो तुम लोग आधी. I am just taking names of those people who have not responded today. Tejashwini, Dhruv, Apeksha. That's a good name. Anybody? No one? Okay, ठीक है, चलो. Let's calculate it. If anyone has got anything or you need more time, you can let me know. Okay, so what you will do first, just take one battery and take current coming out of it, right? Which battery we are going to select? The battery having a higher potential. So, okay, Kiran, that is not the answer actually. Answer will be less than 1. So maybe in the calculation you are doing mistake. ठीक है. So यहाँ से अगर आप देखो 9 volt है, 6 volt है. 9 volt being bigger, I will take current coming out of it. Let's say current I is coming out of it. It's like this. At here, I current will reach. At this junction, current will get divided. Let's say in this branch, I1 current is coming out. Then in this branch, I2 current will go. So here I2, ठीक है, and at this point I2 is again coming out. I1 I2 will get added to give I current. So whenever I mean जब भी तुम current distribute करते हो ना and you want to check you have done correct correction or not, current distribution or not, then you should see from the battery you took out the current, positive terminal say you took out the current, to the negative terminal same amount of current should come in. ठीक है, so that is the check. Dhanush नहीं, answer is less than 1 ampere actually. Let me check if I have written the wrong answer or you people are giving me the wrong answer. Let's check it. ठीक है, so I have to calculate current through this branch. Let's first calculate what. कैसे calculate कर सकते हैं easily. So okay, can we calculate relationship between I1 and I2 by traveling in this single loop? ये जो स्मॉलर लूप है ना, इसमें ट्रैवल करके आप I1 और I2 में रिलेशन निकाल लो. एंड व्हाई इट इज इम्पोर्टेंट, यू नीड टू राइट मोर केवीएल हियर. ठीक है, प्रीवियस केस जैसा नहीं है, लेस केवीएल से काम चलेगा नहीं. सो एक काम करो, सबसे पहले बिगर लूप में केवीएल लिखो. लेट्स स्टार्ट मूविंग फ्रॉम ए बी, बट यू पीपल शुड डू दिस. मैं इक्वेशन लिख देती हूँ, सॉल्व कर लेना तुम लोग. ई एफ ए, ठीक है. सो सबसे पहले ए से मैं मूव कर रही हूँ. वी ए प्लस 9 आई विल राइट, -2i प्लस 6 -3i2 and -3i is equal to VA, right? तुम लोग एक बार ध्यान से देख लेना कहीं कुछ गलत तो नहीं लिखा मैंने. So this is 15 and this is equal to 5i plus 3i2. ठीक है, so this is one relation. Done है. Now, if we calculate what? If we write KVL in this loop, this which loop would we write now? Let's write KVL in A, B, C, F, A. ठीक है? A, B, C, F, A. We need to write more KVL here actually. So, but KVL लिखना मुश्किल नहीं है ना, लिख डालो. A से फिर से मूव करो. VA plus 9 minus 2I minus I1, क्योंकि here this is 1 ohm, and then this side you will go. We are moving in the direction of current, so minus 3I, and this is equal to VA. So this is this VA. ठीक है? Now if you do this, what is this? This is 5I plus I1, right? 5I plus I1 is equal to 9. And we already know one thing, that I1 plus I2 is equal to I, right? From KCL we know this. I is equal to I1 plus I2. So this thing we already know. अब आप एक काम करो, you have equation 1, you have equation 2. What we need to calculate? We need to calculate I1. So try to eliminate I2 from here. So if you try to calculate I2 from here, or write I2 in terms of I1, तो इसको आप क्या लिखोगे? मैं फर्स्ट इक्वेशन में जा रही हूँ, ठीक है? So that was 15. 15 is equal to 5I plus 3. I2 की जगह क्या लिख सकते हो? I minus I1. So this will become equal to how much? 8I minus 3I1. ठीक है? 8I minus 3I1. Now you are having this equation. Let's call 3. Equation 3 और equation 2. अगर आप इन दोनों इक्वेशन को यूज करोगे, you can clearly get the value of I1, because we have two variables and two equations. So should I do this? एक काम करती हूँ, I का वैल्यू मैं यहाँ पे पुट कर देती हूँ. I का वैल्यू सेकेंड इक्वेशन से क्या है? I का वैल्यू इज 9 minus I1 by 5. This is equal to I from the second equation. 9 minus I1 divided by 5. So 15 is equal to 8I. 15 is equal to क्या है? 8I minus 3I1. So 8I की जगह क्या लिखोगे? 9 minus I1 by 5. And this is equal to how much? Minus 3I1. So actually ये क्वेश्चन मैंने इसलिए इंक्लूड किया था क्योंकि इसमें कैलकुलेशन बहुत था. So I felt like कि चलो एक ऐसा भी करना चाहिए. 72 minus 8I1, and this will become how much? Minus 15I1 divided by 5. 5 को इधर लेकर जाओ, this will become 75, and this is 72 minus 15 और 8 कितना हो जाएगा तुम्हारा? 23I1, and this is I1 is equal to 23 by, no, not 23 by, I1 is equal to how much? 3 by 23. ठीक है? 3 by 23. Now this is equal to how much? बताओ किरण. 42 by 23 कैसे? 75 minus 72, that is equal to 3. 3 by 23 करोगे तो क्या मिलेगा? ओके, आई यू आर कैलकुलेटिंग. ओके, ठीक है. सो हमें I1 निकालना था. इसको अगर आप लिखोगे तो 0.1 and then 0.13. So this was the answer basically, 0.13 ampere. Then so we can apply KVL and we can get the answer. चलो अब आज के टॉपिक की तरफ बढ़ते हैं. व्हीटस्टोन ब्रिज हमें पढ़ना है. व्हीटस्टोन ब्रिज होता क्या है? सो बेसिकली व्हीटस्टोन ब्रिज एक ब्रिज जैसा स्ट्रक्चर है जिसमें रजिस्टर्स कनेक्टेड होते हैं. सो बेसिकली यू आर हैविंग 4 रजिस्टर्स. सी हियर, दिस इज योर R1, this is your R2, this is the unknown register, and this is the standard register जिसका वैल्यू हमें पता है. सो R1 का वैल्यू भी पता है, R2 भी पता है, R3 भी पता है हमें, and then R4 we need to calculate by adjusting the resistance of galvanometer R. ठीक है? सो व्हीटस्टोन ब्रिज क्या होता है वो मैं बताती हूँ. इसमें 4 रजिस्टर्स होंगे सबसे पहले. So combination of 4 registers. Let's forget कि known unknown का concept. Let's forget that. तो हमारे पास 4 registers होगा. Let's say this is A, this is B, this is C, this is D. Then across one end, I mean either across diagonal, either AC or BD. Across one diagonal, there will be galvanometer connected. Galvanometer is a device that shows current deflection. since this is a device, it will have some internal resistance, ठीक है, and this is like this. So ऐसे ही स्ट्रक्चर को, पहले तो जो 4 रेजिस्टर्स इस तरह से कनेक्टेड है, इसी को हम क्या बोलते हैं, व्हीटस्टोन ब्रिज स्ट्रक्चर बोलते हैं। ऐसे अगर कहीं भी तुम्हें रेजिस्टर्स कनेक्टेड दिखते हैं, यू विल कॉल इट व्हाट, you will call it Wheatstone bridge structure, R1, R2, R3, R4, like this. And if galvanometer is connected across its diagonal arm and there is no current in the galvanometer arm, suppose कर लो इसको तुमने जैसे यहाँ पे बैटरी से कनेक्ट किया, यहाँ से करंट आया आई, ठीक है, यहाँ पे करंट डिवाइड होगा, लेट से हियर गया, इधर जा रहा है I1, इधर I2. Now if there is no current flowing through the galvanometer, in that case करंट जो यहाँ पे आया है I2, that won't get divided at point B because across galvanometer there is no current. So basically what I want to say is कि Wheatstone bridge दिखता ऐसा है. There is one case where we called Wheatstone bridge balanced, और balanced Wheatstone bridge का मतलब क्या होता है, when current flowing through the galvanometer arm is 0, and if current flowing through galvanometer arm is not 0, then this is called unbalanced Wheatstone bridge. ठीक है, तो अगर मैं यहाँ पे बोलूं कि बैलेंस्ड कंडीशन क्या होगा, बैलेंस्ड कंडीशन का मतलब IG is equal to 0. IG मतलब करंट गोइंग थ्रू गैल्वेनोमीटर, एंड अनबैलेंस्ड का मतलब क्या हुआ, अनबैलेंस्ड का मतलब हो गया कि IG is equal to not 0. Let's say in our diagram, this is a, in our diagram, this is a case of balanced Wheatstone bridge. क्यों? क्योंकि देखो यहाँ पे करंट को डिवाइड नहीं करा है, यहाँ पे I mean I2 करंट इधर है, अगर अगर सपोज कर लो इधर कुछ I3 करंट गया था, ठीक है, and then in this branch some else current will go, and then I mean this current will come from this side. Okay, let me show it more clearly to you, otherwise तुम लोग confuse कर जाओगे, है ना. So let's not go into detail, I would say, because that's not required much here. But still, you should try to solve the balance condition by KVL. I'm not going to do that. You can do it. Why I'm not going to do it? Because you just have to write KVL. ठीक है? तो यहाँ से अगर I करंट जाता है, I1 I2 डिवाइड हुआ, पॉइंट B पे अगर बैलेंस्ड व्हीटस्टोन ब्रिज है, इधर I2 करंट ही चला जाएगा, so I4 will be equal to I2 in that case, है ना. And here also I1 current is coming, and if it is balanced Wheatstone bridge, there won't be current in the arm BD. So whatever current is coming at D will go here, only that current. So here I1 will be equal to I3. So current in this branch is same, and the current here is also same. Whatever is going through this will go through this in case of balanced Wheatstone bridge. And when you will use KVL to write it, you will get that resistance of this arm divided by resistance of this arm, that is equal to R2 by R1 will be equal to R4 by R3. This is the case of balanced Wheatstone bridge. ठीक है, यही एक इक्वेशन है जो तुम्हें बहुत ज्यादा पढ़ना है, बैलेंस्ड कंडीशन. सो बैलेंस्ड व्हीटस्टोन ब्रिज का मतलब समझ गए तुम लोग, ऐसा व्हीटस्टोन ब्रिज जिस केस में जो गैल्वेनोमीटर आर्म है उसके थ्रू करंट नहीं जाएगा, ठीक है, यानी कि R2 और R4 विल बी इन सीरीज. अगर इसके थ्रू करंट नहीं जा रहा, वॉट एवर करंट इज गोइंग हियर विल गो हियर. If there is no current in this branch, then R2 and R4 are in series, R1 and R3 are also in series. And for this balanced condition, R2 by R1 will be equal to R4 by R3. From where we are getting this? From KVL equation. So I will suggest you refer to H.C. Verma textbook. There you will be getting the derivation, or you simply Google it. But before Googling it, do it yourself. Try to take the condition where there is no current flowing through it, and then try to find out the relation between R1, R2, R3, R4. You will get this relation. Okay, so that is your homework basically. Done it? So this is the case of balanced Wheatstone bridge. अब देखो मीटर ब्रिज क्या है. सो बैलेंस्ड व्हीटस्टोन ब्रिज का वर्क क्या है, टू इफ यू नो द वैल्यू ऑफ 3 रजिस्टर्स, यू कैन इजीली कैलकुलेट द वैल्यू ऑफ फोर्थ वन. ठीक है, सो हियर R3 was not known, I mean no, R4 was not known, so we can clearly calculate R4 if we know R2, R1, R3. ठीक है, now there is another device called meter bridge. अब इसमें भी कुछ ज्यादा नहीं पढ़ना तुम्हें. This also works on the principle of balanced Wheatstone bridge. So what is this meter bridge first? So it is also used to calculate unknown resistance. ठीक है, इसका भी फंक्शन क्या है, अननोन रेजिस्टेंस को कैलकुलेट करना. सो व्हाट इज द कंस्ट्रक्शन? कंस्ट्रक्शन में हमारे पास दो मेटालिक स्ट्रिप्स है, ऐसे ऐसे मेटालिक स्ट्रिप्स है, एक ये मेटालिक स्ट्रिप है और दूसरा तुम्हारा यहाँ पे एल शेप का मेटालिक स्ट्रिप. नाउ व्हाट इज हैपनिंग अक्रॉस द मेटालिक स्ट्रिप, और यहाँ पे बीच में एक ऐसा है, देयर इज वन रजिस्टर इंसर्टिंग slab here, and again here also there is one more resistor inserting slab. So यहाँ हमने एक known resistor को insert कर दिया और यहाँ पे हमने किसको insert किया, unknown resistors को. So either of these, either यहाँ पे known को करो, यहाँ unknown करो, इधर unknown करो, इधर known करो, it doesn't matter. ठीक है. So इस केस में S means a standard, so this is known resistance basically. ठीक है, and this R is unknown, we need to calculate. उसके बाद हमने क्या किया, उसके बाद हमने एक वायर लिया, 1 मीटर लॉन्ग वायर होता है. अगर क्वेश्चन में कुछ नहीं लिखा है, देन यू विल टेक द लेंथ ऑफ दिस वायर टू बी 1 मीटर. सो दिस इज 1 मीटर लॉन्ग वायर विच हैज रेजिस्टेंस बेसिकली. लेट्स से इट्स टोटल लेंथ इज 1 मीटर. ठीक है, एंड इट्स रेजिस्टेंस इज समथिंग आर समथिंग. ठीक है, नाउ व्हाट वी विल डू, वी विल टेक अ गैल्वेनोमीटर. वी आर टेकिंग गैल्वेनोमीटर and then there is a brush sort of thing. ये एक pointed end जो दिख रहा है ना, this is a brush, and what we do is we slide this brush onto this 1 meter long wire to get a point, to discover a point where deflection through galvanometer will be 0. So हम क्या करते हैं ना, इस ब्रश को जनरली इस 1 मीटर लॉन्ग वायर पे क्या करना है, हमें इसे स्लाइड करना है, and we will slide it, we will see where the deflection is becoming 0. Let's say here deflection is becoming 0. I mean हमने इसको यहाँ टच करवाया और यहाँ से जैसे ही इस पोर्शन को टच किया, we are getting 0 deflection. What is the meaning of this? अब इसको आप तोड़ कर देखो, देखो ये it is looking like Wheatstone bridge. कैसे? Let's say this is R, ये R था, ठीक है, and this is your A and this is your B. अब B से C की तरफ एक और रजिस्टर है, so let's call it C, and this is your S, this is your R. Then there is this wire. ठीक है, since यहाँ पे null point मिला है, null point मतलब ऐसा point जहाँ पे deflection through galvanometer is 0. Since that is a null point, we will say that I mean this null point is dividing wire, 1 meter long wire into two length. One is L1, another is 100 minus L1. So basically this L1 length of the wire, जैसे deflection तुम्हारा कहाँ मिला है, suppose करो 0 deflection, यानी कि null point यहाँ मिला है. So this length is L1 and this length is 100 minus L1. Length का measurement हम लोग करते हैं किस साइड से, लेफ्ट हैंड साइड से करोगे. तो यहाँ से मेजर किया, L1 मिला, तो रेस्ट कितना हो जाएगा, 100 minus L1. ठीक है, so L1 length will have certain resistance. Let's say its resistance value is R1 and 100 minus L1 length has a resistance of R2. So A से यहाँ पे एक और resistor है, it has a value of R1 and then this is another, this has a value of R2 and galvanometer is connected from B to D. Let's say this is D, है ना, क्योंकि A से D तक L1 length है, it has a resistance of R1. D से C there is another length, 100 minus L1 which has a length of R2. So I have written like this. Galvanometer कहाँ है, देखो B से D की तरफ है galvanometer and there is no deflection in the galvanometer. So what you will say here, आप यहाँ पे simple ये बोलोगे कि since there is no deflection, R by R1 is equal to S by R2. Why we are writing this? From the case of balanced Wheatstone bridge, right? धनुष, कल क्यों नहीं क्लास होगा, कल क्या है, कल कुछ है क्या? कल तो क्लास होनी चाहिए ना, कल क्या है? यू आर कंफ्यूजिंग मी. ओके, टू माई नॉलेज दे विल बी क्लास. ठीक है, सो R1 R2 को लेंथ के टर्म में क्या लिख सकते हो, सिंस दिस इज अ 1 मीटर लॉन्ग वायर, दिस वायर विल लुक समथिंग लाइक दिस. ठीक है, कुछ ऐसा दिखेगा. इट हैज अ लेंथ ऑफ L. ठीक है, and it will have certain area of cross section. So R1 can be written as what? R by R1 को क्या लिख सकते हो, रो L1 by एरिया ऑफ क्रॉस सेक्शन. सिमिलरली R2 को क्या लिख सकते हो, रो लेंथ 100 minus L1 by A. So this will get cancelled. Rho and A are same for both the reason, both the portion because both are part of the same wire. So यहाँ से अगर आप लिखते हो तो इक्वेशन क्या मिलेगा, R by L1 is equal to S by 100 minus L2. So this is the equation of meter bridge that we will be getting. मीटर ब्रिज में तुम्हारा क्या होता है, बेसिकली अगर गिवन है फॉर L1 लेंथ पे यू आर गेटिंग, suppose it is given that as 20 centimeter length, you are getting null point. Calculate the value of S. R is 10 ohm. So you will simply put the value of resistors length and you will get the answer by putting in this equation, right? So this is your meter bridge. Kal ki class mein I will be again taking one last class on current electricity. So I will take you through converting galvanometer to ammeter voltmeter, and also I will make you understand more this Wheatstone bridge and meter bridge. I hope you have understood it, but I will explain this again. Okay? Yes, Kiran, I will do that. So मैं ये कहना चाह रही थी कि Kiran, can you let me know which is the portion you couldn't get? You can unmute yourself. Don't worry. देखो, अगर मैं फिर से समझाऊं तो तुम्हें मैं सब कुछ डिलीट करती हूँ एंड आई विल मेक यू अंडरस्टैंड मीटर ब्रिज ना पूरा ही. सो कंस्ट्रक्शन पे पहले बात करते हैं. कंस्ट्रक्शन में क्या क्या है तुम्हारा, टू मेटालिक स्ट्रिप्स हैं, ठीक है. सो टू मेटालिक स्ट्रिप्स, और क्या क्या है तुम्हारा, एक है स्टैंडर्ड रेजिस्टेंस, एक होगा तुम्हारा स्टैंडर्ड रेजिस्टेंस एंड अनदर इज योर नोन रेजिस्टेंस. और क्या है तुम्हारा 1 मीटर लॉन्ग वायर. एंड व्हाट एल्स यू नीड, यू नीड मीटर स्केल. मीटर स्केल यू नीड टू मेजर द नल पॉइंट डिस्टेंस, ठीक है. सो दीज आर द थिंग्स वी नीड. अब देखो, ये एक मेटालिक स्ट्रिप है, ये दूसरा है, एंड दिस इज द अनदर मिडिल वन, ठीक है. सो वी आर यूजिंग बेसिकली एल सेप टू मेटालिक स्ट्रिप्स में यहाँ कहना चाहती हूँ, ठीक है. So across one we connected known resistance. This is known. Sorry, this is unknown basically. S is standard. Standard means something that is known. Okay. So R here is what? R is your unknown here. And this is S is what? This is known. What is our target? Our target is to calculate the unknown with the help of S. Okay. For that we have taken again, there is a 1 meter long wire. So this wire will have certain area of cross section and it has certain length. Length is ideally 1 meter. If nothing else is given in the question, then you will be taking length to be equal to how much? 1 meter long. So 1 meter long will be the length of the wire. Okay, give me one. ठीक है. So this is this. अब आप देखो क्या करोगे. You have a galvanometer here. Again, I will include here. One galvanometer you need. Galvanometer does what? It measures current. ठीक है. So basically, if there is current in this branch, in this galvanometer wire, then this galvanometer will show blinking thing. It will show deflection. Okay? If there is no current, it won't show deflection. In the meter bridge, in order to measure this unknown resistance, what is our target? Our target is to get a null point. That is what we are doing here. Galvanometer jo hai tumhara, that is connected with a brush. And we are sliding this brush on the 1 meter long wire. So we are sliding it on this. And we will slide it. Why we are sliding it? To get a position where there will be null point. So we will move it on this wire and at a certain point, suppose let's say here, when we brought it here, brush, we got no deflection in the galvanometer. Done it? What does it mean? It means that it is no current is flowing through the galvanometer. And when no current is flowing through the galvanometer, this circuit will look like balanced Wheatstone bridge. So circuit कैसे बनाओगे? Balanced Wheatstone bridge का, this is your A point ले लो, this is B, and then B to C there is resistance S, here there is R, and then A to D there is L1 length where we have got the null point. So let's say it has a resistance of R1 and 100 minus L1 has a resistance of R2. Then this is D. This was C, right? So this is this, and galvanometer is here. If there is no deflection in galvanometer, R by R1 is equal to S by R2. इसलिए मैंने लिखा R by R1 is equal to S by R2. R1 can be written as rho L1 by A. So वहां से मैंने लिखा था R by rho L1 by A will be equal to S by rho 100 minus L1 by A. ठीक है? So यहाँ से you will get the value of R by L1 equal to S by 100 minus L1. Is it clear, Kiran? Internal, okay, Kiran. Internal resistance of which wire you are talking about? 1 मीटर लॉन्ग और गैल्वेनोमीटर आर्म की बात कर रहे हो, श्रव्य? वन मीटर लॉन्ग का रेजिस्टेंस ही तो कवर कर रहे, कंसीडर तो कर रहे ना. This 1 meter long has a resistance, right? So this null point divided this wire into two portions, L1 length and 100 minus L1 length. L1 length का ही resistance तो मैंने R1 लिखा है, 100 minus L1 का ही resistance तो R2 लिखा है ना. So obviously we are considering this resistance. Without that, how we will do? It's not possible, right? Anyway, कल फिर से मैं explain कर दूंगी तुम लोगों को if you are having doubt then. And tomorrow for sure we are going to end it. ठीक है? We will learn converting galvanometer to ammeter. ठीक है? Anyone has any other doubt? Let me know.
No.
Okay, thank you. Thank you. Bye. Bye-bye, Kiran. Thank you, everybody. Thank you for your time. Keep on solving more number of questions until we meet tomorrow. ठीक है? Bye, everyone. Anush, bye-bye. So who? Bye-bye. What's your name? Is this your name? चलो ठीक है, bye-bye. Hello, bye, everyone. Okay, that's great then. I will be calling you by this name. No worries. Okay. Okay, everyone, take care. Have tea.